Welcome to Chapter 5, Section 3, Dimensional Analysis. In this unit, we're going to work with using conversion factors to solve rate problems. Now, a conversion factor is when you look at the labels, like feet and inches, and use those to plan the way of solving problems. Dimensional analysis, because of this reason, is also called the factor label method. You have one vocabulary word, and a conversion factor is when you multiply by one or more ratios of equal quantities. An example of doing this is when you convert inches to feet, you would use the ratio below as a conversion factor. When you look at this, notice that 1 foot is equal to 12 inches, so in effect is equal to 1. We're going to find the appropriate factor for each conversion. In this case, we're converting feet to yards. Well, how many feet are there in 1 yard? If you don't know this, if you look in your agenda, there is a chart that will show you this. There are 3 feet per yard. So to convert feet to yards, we're going to multiply the number of feet by 1 yard equals 3 feet. And we'll see how this works in just a few moments. Example B. There are how many ounces in a pound? Well, here we're going to convert ounces to pounds. There are 16 ounces in a pound. So to convert pounds to ounces, we're going to multiply pounds by 16 ounces per 1 pound. LB is the symbol for pounds. You're going to see it, in effect, these are going to start canceling out, and I'll show you how that works. Let's look at example 2. The average American uses 580 pounds of paper per year. We want to find the number of pounds of paper the average American uses per month. That's 1 month to the nearest 10th. We're going to multiply the ratio by the conversion factor. Okay. So we have pounds over years is equal to 1 year is 12 months. This is our 1. This is our conversion factor. 1 year and 12 months is as a fraction, if we put these both into months, would be equal to 1. So what's going to happen is this year and this year is going to cancel out. And so we're going to have 580 pounds over 12 months. Notice how the years canceled out, and that left us with pounds per month. And then, of course, it's 580 times 1, and 1 times 12. And then we're going to go ahead and divide this, which equals 48 and 3/10 pounds per month. So the average American uses 48 and 3/10 pounds per paper per month. Now notice what happened here. We set up our conversion factor so that the years would cancel. And that's how we knew what to put on top in our conversion factor. Let's look at example 3. A car is traveling 60 miles on a road in 2 hours. How many feet per second was the car traveling? Well, we know our rate is 60 miles per 2 hours. We're going to multiply that by conversion factor. And we want feet per second. Oh, well, we got feet and miles. So we're going to have to do this twice. Once to change miles to feet, and once to change hours to second. Now to change miles per feet, miles is on top right here. So we're going to put miles on the bottom, and we're going to put feet on top. And I chose miles on the bottom so that we can eventually cancel those 2 units out. And that's how we know how to set this up. So in 1 mile, there's 5,280 feet. So we're going to cancel this out, and we now have 316,800 feet over 2 hours. Make that a little neater right here where I have a little more room. So we now have 316,800 feet per 2 hours. We're going to multiply that, and this time we're going to get rid of hours and make it per second. So we definitely want seconds in the bottom. But not only do we want seconds in the bottom, our hours need to be on the top to cancel out. Well, we know in 1 hour there is how many seconds? So we know in 1 hour there is 3,600 seconds. Our hours will cancel, And we will have 316,800 feet over 2 times 3,600, which is 7,200 seconds. And then it becomes a division problem, so we're going to divide by 7,200, and we're going to get that this equals, when we divide it out, 44 feet per 1 second. And I got that by dividing both the top by 7,200 and the bottom by 7,200. So our answer is 44 feet per second. Now our first step may be to eliminate the fraction, because this 1/100th can be quite a bit difficult to work with. And we can do that by multiplying both sides by 100, the numerator and the denominator. In that case, we'll have 5,200 centimeters per 1 second. So we now have a centimeter per second. Now we need to convert the centimeters per second to meters per second. So we will have 5,200 centimeters per 1 second times 1 meter over 100 centimeters, and that's our conversion factor. These are equal. 1 meter is equal to 100 centimeters. We multiply that through, our centimeters will cancel, so we know everything is in the right spot. So we're going to have 5,200 times 1 meters, and 1 second times 100, which will be 100 seconds. And then of course we can reduce by dividing by 100. So we now know that the object is traveling at 52 meters per second.